Hello everyone. I mentioned about four major methods of company valuation, and I would like to start with the first and the most widespread one, the discounted cash flow model. So first of all, this is a basically introduction type of video, so I'm not going to go through all the details of this calculation, but to give you a basic sense of how it's done. So for discounted cash flow model, you need four major things. First, you need the flows of cash. So how much cash flow you're expecting for the next foreseeable future, for the next 5 years or 10 years or whatever. And next, you will need a growth factor for the next, close future, a discount factor, and the calculation of discounted cash flows. So in my case, for the cash flow, I take 10 years of cash flows estimates. So I start with the year 0, which is this year, and then I go with year 1, 2, 3, 4, 5, and then all the way to 10. I will get to the terminal value later at the end of this video. So these cash flows are growing at a rate of 18% for the beginning, and then slowing down to 15% for the third and fourth years, and then to 12, 9, 6% levels. So why? This is just the estimates on my part, but you can do this estimate if you're able to estimate the next the foreseeable future for the next 5 years more accurately. Then you can keep this model to 5-year horizon, so you can calculate the terminal value at the end of the 5th year instead of at the end of the 10th year. So it's just up to you. The model will be more accurate as many years as you add, and but on the other hand, it will be hard to estimate the growth factor for the future if you make it too long. So there's the trade-off of this model. On the discount factor, so this is also called WACC, weighted average cost of capital. It's basically a discount factor for this specific company, for the cash flows that you're calculating, that you're growing every year. The company will have a kind of a cost of capital. Why it's called weighted average cost of capital is because let me put it here also, so that you know what I'm talking about. So it's called WACC also. So why it's called weighted average cost of capital? Because some companies are funded by equity and some companies are funded by debt, but most companies are funded by a mixture of both of these. So they both take debt and equity. So in this case, you just look at the cost of capital in terms of debt, and so cost of debt, and you look at the cost of equity, and you just take kind of a weighted average of these two to come up with a discount factor for the specific company. So in this case, I take the WACC or discount factor to be 6%, which is pretty low number. Normally, if this company would be a startup company, it would be much higher discount factor because there will be more risk. So the company would have had a hard time to get equity or debt. In that case, their cost of capital will go up, hence the discount factor. By the way, the higher discount factor, the lower the company value. And you will see this in the calculation phase. So once we set all these up, we come up with the discounted cash. So first of all, let me show you also how the cash flow goes up. So to build the growth into the cash flow, so you have on year 0, you have 1,000 cash flow, and then after 18% growth, it goes up to 1,180, and it grows in the second year another 18%, which goes up to 1,392. So it's just a basic calculation of growth, as you can see here. So after I have all these cash flows in their own respective years, I need to discount these with my discount factor, which is 6% for every year. How do I do this? How do I formulate this? So first of all, year 0 goes as is, which is 1,000. You don't discount year 0 because you're already taking this. Technically, you can be getting these cash flows on year 0 in different months, so you might need to discount them on a monthly basis, but I wouldn't go into that detail of that. For year one, what you do is the formula here goes. You take the cash flow for year one, the nominal cash flow, which is 1,180. You divide it by 1 plus the discount factor to the power of the number of years. So in this case, 1,180 divided by 1 plus 0.06 to the power of 1. And the next one, well, you guessed it, it's gonna be to the power of 2 instead of to the power of 1. The rest will be all exactly the same. What this means is, since you're dividing the nominal value of cash flow by the discount factor, and as the years go by, you have to take exponential factor of the discount, the exponential version of the discount factor, so that it means you're taking into the effect of compounding of the discount factor. So if you go to the year number 3, you're dividing 1,601 to 1 plus 0.06, which is 6%, to the power of 3. As you notice, the growth rate is higher than the discount factor, at least for the foreseeable future, for the first 8 years in this case. So that means your discounted cash flow is growing. But once you start hitting the rate of growth being equal to discount factor, then your discounted cash flow becomes identical after year 8 in today's value. So that means you're not adding anything up on top of the discount factor. You're just being a going concern as a company. You're just bringing in whatever you bring in as a growth is going down by the cost of capital. This is usually a harsh estimate, but in my case, I just modeled it this way. So once you do this for all 10 years, you come up with some discounted cash flow total, which is, in this case, let me add these up. Here, you have 16,165 as the first 10 years discounted cash flow total. But this is not enough. Why? Because this is a company built as a going concern, so it's gonna go forever, ideally. So that means you will have a terminal value, which means after the year 10, you will have to come up with some kind of an estimate for the future value of the company. Because at the end of 10 years, this company will not be worthless. It's gonna have some kind of value, and terminal value calculation is something to use to calculate this future value. So what you do to calculate the terminal value in this portion of the table is, first, let's look at the cash flow in the year 11 in this case. So what we do is we take the last nominal cash flow, which is 3,084. We multiply this by 1 plus growth rate, 1 plus 0.02. And this is our 11th year cash flow. And then what the formula says for terminal value is that once we find the nominal cash flow for year 11, we just divide it by discount factor minus growth. So this means 6% minus 2%, which is 4%. So that's the formula for terminal value. So number 11th year cash flow, nominal cash flow. Or if you're doing a 5-year model, then it's going to be 6th year cash flow. Doesn't matter, it can be 16th year nominal cash flow. It just depends on your model. You just come up with, in this case, 11th year nominal cash flow, and then you just divide it by discount factor minus growth rate. So this is a value you found for the value of the company following year 11, so 11, 12, 13, 14, 15. So that means this value is 78,632 is at the year 11 right now. So you have to take it back to today's value. So you do it at the bottom here. You just do it just like you did here, bringing 10th year cash flow to today's value, bringing 9th year to today's value. You will just do the same calculation here Once you find the terminal value, bringing it from number 11, year 11 to year 0 will be much easier. So you just take 78,632. You divide it by 1 plus n7 in this case, which is 1 plus the discount factor to the power of n4 plus 1, which means 11 basically. So you just take the terminal value in year 11, you take it all the way down to today's value, which becomes 41,422. So to come up with the calculation of the total present value, you add up everything you see here. So including year 0, including year 1, 2, 3, discounted cash flow, and all the way to the terminal value's present value, which gives you a total of 57,588. One assumption here you have to make is that when you're calculating the terminal value, you have to come up with some kind of a growth estimate. In this case, I was very conservative. I took 2% growth, which means after year 11, this company will grow cash flows by 2% every year, which is very conservative, but you know, it's a long time. Even with 2%, you can see how high the terminal value is. If you make it 3%, as you see, the terminal value goes up. If you make it 4%, it goes up like crazy. As you can see, the value almost doubled by doubling the terminal value growth estimate. So taking it back to 2%. So that's one assumption you have to make, and besides all the growth assumptions, the discount factor is usually a calculation. It's a messy calculation. It's pretty complex. I will not go into the detail of that today, but in this case, you can assume discount factor. If you don't know anything about how to come up with a WACC or discount factor, you can basically take the cost of debt for a company. If you go to a bank and if you want to take a corporate loan for your own company or for the company that you're looking into, analyzing into, you just look at, you know, the rate that they can be allowed to borrow from the public market. If that is 8%, then you can use 8% to come up with a basic discount factor. It can give you a basic estimate for a discount rate, but if you want to do a more thorough analysis, you have to come up with an detailed calculation for WACC, weighted average cost of capital. So thank you for listening. Bye.